Hey guys, hope you're doing well. So now this next segment is going to be solving simultaneous equations. Okay, just the same purpose and goal as what we did with substitution, but in this case we're going to do it with the process of elimination. There's going to be a couple of examples that I'll be doing in this clip, just because it is a little bit more complicated to get your head around, to understand what you need to do first. So hopefully this video is going to do it justice and make it clear for you guys. So the idea is we won't have two equations always fitting the description of y equals mx plus c, and then you have another one the same y equals mx plus c. You're not going to have that all the time. Sometimes you'll have something like say 2x minus y equals 6, and then the second one could be 3x plus y equals 10. Or possibly you have minus 5x plus y equals minus 2, and then you have on the other side 6x plus 3y equals 5, and the structure of the linear equations don't really match up. You need to play around with it and do a whole few things to make it work. So let's ignore all of this stuff for the moment and then let's work through a couple examples of what you actually need to do. So I'm going to take this slowly and hopefully it will be okay for you guys. Alright, so I'm going to use these two examples, x plus y equals 6, and the next equation is 3x minus y equals 10. Okay, so this is going to be equation 1. This is going to be equation 2. Okay, so two equations, and we're wanting to eliminate certain aspects of it. Okay, in this case, let's focus on eliminating y, okay, and solving for x. So what you would do is to, in order to actually get rid of it, positive y minus y is going to be 0. Okay, what I'm actually going to do is add both equations. Okay, and I'm going to do a couple more examples, and hopefully that trend will be a little bit more clearer of what you're actually aiming to do. So we want to eliminate one of the pronumerals. Okay, I'm going to eliminate y. It's always a good starting point to do that. And to eliminate it, you're wanting to add the two equations together. And I don't have to manipulate or modify any of these equations, because simply that plus that is going to cancel each other out naturally. Okay, so x plus 3x is going to be 4x. Okay, that positive y plus negative y, they cancel each other out, so it's 0, which is exactly what I want. And then 6 plus 10 is going to be 16. Divide both sides by 4, and then x should equal 4. So I've worked out through the process of elimination that the coordinate for x, so this is, remember, this is the point in which the two lines actually intersect with each other, and so far I found the value for x, that is 4. The next step that I want to do is then substitute. Okay, so substitute x into one of the equations. It really doesn't matter if you want to use the first one or the second one. So let's do the first one because it's just simpler. If x equals 4, okay, so then we have 4 plus y equals 6. So I'm just going to say substitute into first equation to solve for y. Okay, so 4 plus y equals 6. I'm going to subtract 4 from both sides. That way y equals 2. 6 minus 4 is 2. I have the value for x, I have the value for y, so the point at which the two lines intersect each other, x is 4 and y is 2. Okay, hopefully that has made some sense. I'm going to go through another example in which we would actually have to do a little bit of modification with these guys to get to where we need to be. Okay, so second example is y minus 3x equals 1, and then 2y plus 5x equals 13. Okay, so that's equation 1, that's equation 2. I am wanting to eliminate the y's. Okay, but what you would really need to do first, notice that in this case, this is one y, this is another y. If you simply add them, you get 0. If I add these, I don't get 0, so that doesn't work. If I subtract one from the other, that's also not going to work, because 2y minus y is just 1y. It doesn't eliminate it. Okay, so remember, this process is through elimination. What I want to do first is to modify one of these equations so that the pronumeral of y, or the coefficient of y, does equal the other equation. Okay, so simply, hopefully that made sense, I want to double this first one, so then I get 2y. Alright, so I'm going to multiply equation number 1 by 2. Alright, so I will have 2 times y is 2y, 2 times minus 3 is going to be minus 6, and then 1 times 2 is 2. So if I'm multiplying it by 2, I'm going to do it for every single component of the equation, okay, not just the first part. The second equation, I'm going to leave it as it is, okay, because that's fine. Now I have the 2y and the 2y exactly the same. That's where I want to be, okay. In order to eliminate these two processes, I'm going to subtract one from the other. So this 2y minus 2y, okay, because they're both positive, and that way it will eliminate those two parts altogether. So 2y, I'm going to subtract. I'm going to call this number 1 and number 2. Subtract number 1 or number 2 from number 1. Okay, so 2y minus 2y becomes 0. Minus 6 minus 5 is going to be minus 11. Okay, because I'm subtracting. 2 minus 13 is going to be minus 11 again. Okay, to get rid of minus 11, I'm going to divide both sides by negative 11. So x will equal 1. Okay, now I've solved for 1. I then substitute it back into one of these equations. The first one will be ideal. So substitute value for x back into first equation to solve for y. Okay, so if x equals 1, let's use this equation up here. Y equals, now if x is 1, minus 3 times 1 will be, oops, sorry, that's a minus. So 1 times minus 3 is minus 3, and then equals 1. Okay. To get rid of the minus 3 here, I'm going to add 3 to both sides, and y will equal 4. So I've got the value for y, I've got the value for x, so the point of intersection, or the solution for these two equations, or the point at which those two lines intersect each other, is 1, 4. Okay, x is 1, y is 4. Alright, I'm going to do one more example, just hopefully just to reinforce everything. Let's see. Let's use this one here. So we have 3x plus 2y equals 6. That's my first equation. And then I have 5x plus 3y equals 11. That is going to be my second equation. So as you can see that they're both different. I can't multiply this to equal 5 or 3. I can't multiply this equation to anything to make that equal. But what I could do is find the lowest common multiple to eliminate y, and that's going to be 6. Okay, so to get this into a 6y, I need to multiply this equation by 3. Okay, and to get this 3y into a 6y, I want to multiply this equation by 2. Okay, so let's put that into action. 3 times 3 is 9x. Okay, 3 times 2 is 6y. And then 3 times 6 is 18. So that's going to be the modified version of equation 1. Let's do the same with equation 2. In this case, I'm multiplying it by 2. So 5 times 2 is 10x. And then 3 times 2 is 6y. And then 11 times 2 is 22. That's going to be my new equation number 2. Alright. Notice that now I have the y values exactly the same. That is perfect. That's where I want to be. And simply to eliminate one from the other, I'm going to subtract equation 2 from equation 1. Okay, so, or actually what I will do in this case, because I don't want negative things, notice that this x is bigger, this number is bigger than the top one. Let's reverse everything together, okay, and hopefully this will make sense. Always try to deal with positive numbers, because sometimes negative numbers is just messy. Okay, so I'm going to subtract number 1 from number 2. Okay, so top from bottom, 10 minus 9 is just going to be x. Okay, it's just 1x. 6 minus 6 is 0. We've eliminated y, which is perfect. 22 minus 18 is 4, and now I've solved for x. Okay, the value for x is 4. Substitute it, okay, back into one of the original equations. It really doesn't matter. First one will be great. If x equals 4, we have 3 times 4, okay, is 12. Then plus 2y equals 6. Okay. Let's eliminate 12 by subtracting 12 from both sides. I have 2y equals minus 6. And then lastly, to eliminate the 2, I want to divide both sides by 2. So I have y equals minus 3. So what I've done here now, I've solved for y, I've solved for x. The coordinates, or the point at which these two equations meet or intersect each other, is at 4 minus 3. Guys, I hope that has helped you and has been clear. Feel free to let me know if you have any questions, if you're still stuck with anything. Okay, thanks guys.